Now we're up to big step 6. And remember, glycolysis has 10 steps, so we're more than halfway done. So let's look at big step 6 in glycolysis. Big step 6. And you'll remember big step 6 is special because it's the only step in glycolysis that deals with phosphates where you're not using ATP. Instead, we're going to get our phosphate group from HPO4 2-, which is an inorganic phosphate. So let's look at what that looks like. By now, we've converted all of our DHP, DHAP into glyceraldehyde 3-phosphate. So let's draw glyceraldehyde 3-phosphate. Now remember, at this point, we actually, in the cycle, have 2 of these because we've converted the DHAP into this. So from this point on, all the compounds we have that we're drawing, there are actually 2 of. Here's glyceraldehyde 3-phosphate. So now what is that going to become? Let's go back to our mnemonic. G, gaffas, chef. That the C was the convert that we just did. We converted DHAP to glyceraldehyde 3-phosphate. Now here's our clue for the next compound. Gaffas, chef, bis 8. The bis stands for the bis, the 2, and it's telling us that this compound is going to end in ATE. Let's see what this compound looks like. Remember, only steps 1, 3, and 10 are one way, so I'm going to put a 2-way arrow in for big step 6. One, 3, bis, let's bring it up, phosphoglycerate. That's my dog. He's bad. Okay, notice when we get to this point that up until then we had our compound name and then a number where the phosphate occurred. Once we get to 1,3-bisphosphoglycerate, notice the numbers precede the name. So what is this name telling us? It's telling us this is a 3-carbon compound that has 2 phosphates. The glycerate is telling us that it has 3 carbons, and it's derived from glycerol, and OL means OH, or alcohol. But now, what does this ATE mean? When you see ATE in an organic compound, in a compound that has carbons and hydrogens, that means you have this group. You have a carboxylate. Carbo means carbon and oxy means oxygen. And in this case, with a carboxylate ion, ATE, you must have this CO2 with a negative charge in there somewhere. Now, sometimes they add something to that O, which in this case we're going to add a phosphate group. Once you have this functional group where something is added onto a carboxylate ion, this is called an ester. So let's look at how to draw 1,3-bisphosphoglycerate. One 3-bisphospho glycerate. Well, it's a 3-carbon compound. We know that because of GLY. And it has an ATE, so we know we're going to have this COO negative. Now, I could have drawn it this way, and I think I will, because we're going to have to add a phosphate group to that. Let me move the paper down. 1, 2, 3. Here's our carboxylate ion because we have an ATE ending, 1, 3, bis-phosphoglycerate. That's our functional group, so it's got to be as close to C1 as we can get it. So let's put it right on C1. So on C1 and on C3, we have a phosphate. So let's go ahead and put a phosphate on the oxygen of the carboxylate ion and on the C3 oxygen. And again, since it's derived from glycerol, we have that OH group in the middle. So that's our big step 6. Let's put it all together. We're starting with glyceraldehyde 3-phosphate. Here's our aldehyde. Glyceraldehyde 3-phosphate. And for big step 6, we're turning that into, sorry, we off the paper. We're going to be turning that into 1, 3 bis phosphoglycerate. You can hear that my dogs enjoy glycolysis very much. Here's our 3-carbon GLYC. Here's our ATE ending, our phosphate ester. We're derived from glycerol, so we have an OH there. And for the OH on top, we're going to be adding a phosphate because it's 1, 3 bis phosphoglycerate. Now, where did this phosphate group come from? We know it's big step 6. So our phosphate group is coming from HPO4 2 minus. That's going to bring a phosphate group onto our bis-phosphoglycerate. All right, so we're doing great so far. We're up to it's not big anymore, just step 7. And so far we've covered the G, add a phosphate, the fructose, add a phosphate. We've split our compound into DHAP and glyceraldehyde 3-phosphate. And the chef is where we convert. We converted DHAP to glyceraldehyde 3-phosphate. And then we have the compound we just did where he buys 8. And that was a 1, 3 bis phosphoglycerate. Now what happens in step 7? In step 7, we see he buys 832 peppers. So we're up to the 3. Now we left off step 6 with 1, 3 bis phosphoglycerate. So let's go ahead and redraw that. 1,3-bis phosphoglycerate. But now the next number that in our mnemonic is telling us we just have a 3. So now we know in this next step we're just going to end up with a 3-phosphoglycerate. Annie, could you put those dogs outside before I hurt them? So we're going to be losing a phosphate group from C1. Let's redraw this entire molecule, and we're just going to leave the phosphate group on C3. Once the phosphate group leaves C1, we're left with just a plain old carboxylate ion on the bottom. And everything else stays the same. Now, where does this phosphate go in step 7? Well, if I was a phosphate, I'd want to grow up to be something important. So this phosphate that leaves is going to come join ADP and produce ATP. We don't need to add a hydrogen in here because we're just going to be staying as a carboxylate ion. The next structure is very simple. We had 832. Well, the 2 is telling us now we just want a phosphate on carbon number 2.